Okay, so we're going to share. Let me share the PowerPoint. And okay, so here we are. We're going to talk a little bit now about investment analysis, because this is kind of the first step in the process of figuring out how to get those costs and benefits in the same year. And so that's a bit of a technical problem. This is really finance is what we're going to talk about. So it's just a technical process that you have to go through. So let's go ahead and go to our slideshow. So first of all, we kind of agree that $1 you have today is not equal to $1 that you have to wait for. That is really the basic premise behind modern finance. And in my personal opinion, it's what prevents us from being sustainable in market-based economies, because as soon as you have to be paid to wait, then we're not going to want to wait. So this means we're not going to move to the sustainability position. And it's really the thing that I think social scientists need to worry about, is how to get people to be more willing to wait and to think further ahead than, say, 20 years, which, as we learned about last time we talked yesterday, that if you have a cost of waiting that's really equal to what you earn in the stock market, you're not going to want to wait more than 20 years, because waiting more than 20 years doesn't really have a value today. So what we use to equalize these two things, the today dollar and the tomorrow dollar, is something called the discount rate, which is essentially the interest or the cost of waiting that you put in the formula. And what it really is, should represent as you're coming with an estimate of it, is what is the person's willingness to wait. And I'm just going to make it very clear that when you're very poor, you cannot wait. You can barely think about Friday. Can't feed yourself this week. And you want me to think about 100 years from now or 20 years from now. So this is really why social equity becomes so important in sustainability, and why we really need to think about this in a very holistic manner. And there's kind of two ways we can do this. We can move today's dollar to tomorrow, or tomorrow's dollar to today. If we're moving today's dollar to tomorrow, you're going to calculate what's called a future value. You're going to take that dollar and move it to the future. And many times this is used in personal finance, because most of us have savings goals for the future. And so in most cases, particularly when we get to the examples, you'll see I call it the Get Rich Quick seminar. It's really looking at moving that money to the future. The other way that we'll be mostly primarily dealing with here is worrying about benefits and costs that we incur in the future and moving them to today. So that's what mostly we're going to do in this class, although the first homework kind of does let you try other options. So we're going to learn how to do that today, because it's the first homework. So now, if we were going to do a future value, here's an example. So if you deposit $100 in an account paying 4% annually, how much would you have in the future? Technically, the formula for doing this is to take this $100 and you get interest the first year, then you get interest the second year, and this is what we call compound interest, because you're making 4% on this 4% right here. And then you're making 4%, 4%, 4%. And at the end of the day, you will have $112.50 in 4 years. So this is very common formula that you might, or a common calculation that you would use in personal finance. We're not going to do that much here, but a lot of my students that take this class will also do their personal financial stuff using the same sort of stuff that we're going to learn in this class. So that's really moving money in the future. And if you take a Get Rich Quick seminar, it's called compounding. So you're earning interest on the interest. So when you're saving, it's important to just keep saving, 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 because you earn interest on the interest, and that's called compounding. So your money can grow very quickly because of that. If you're getting above a 10% interest rate, it can grow quite quickly. And that's why the stock market is a good investment, because it returns a lot. Now, let's say you wanted to move money from the future back to today. So this would be a present value. So someone offered you a choice, $285 today or $100 a year for 3 years. What is really the value in today's dollar of these future $100? You can't make a decision because you're offered this or you're offered this. Well, what does this look like in today's dollar if you have a discount or opportunity cost of waiting or interest rate of 8%? So let's take this $100 you received in the future and figure out its present value. So this is the one that you only waited 1 year. So this is the $100 you received in year 1. This is the $100 you received in year 2. And this is the $100 you received in year 3. So what you're doing with this division is reducing the size of this $100 because you had to wait a year. This one you had to wait 2 years, so you're dividing by a number greater than 1. It will reduce that $100. And this one will be 3 years. So if you got to wait 3 years, this is only worth $257.70 in terms of today's dollars. So you're gonna not wait. And this is one of the problems. When you don't wait, then you're gonna want this instant 285. And the 285 is a better deal because if you wait, as we calculate the present value of this $100, $100, $100, year 1, year 2, year 3, it's worth $257.70. So you're not going to want to wait, and that's very common.
It sucks. Every day you're just like, oh, what am I going to die? I'm already 100.
Liana, do you have a question? Okay. So there's 3 different ways you can do this. You can do this by hand using these formulas I just showed you, which is how I used to do it when I was in high school, because I learned about this in high school in accounting class, which I took in 10th grade. Or you can use tables. And in the back of your book, there's tables that will give you these factors that you can use to move around $100. So when I got to college, this is how we did it. So in the very back of your book, you will see on page 341, 2 different sets of tables, discount and annuity factors. So discount is actually if you move $1 for the prescribed number of years and for the prescribed discount rate. The other option is annuities, and this is where you get the same amount every year and you wait however many years. So you can use the tables. But what I recommend you do is use Excel. And why do you use Excel? Because you notice when we looked at these formulas, we actually, can we go back? When we looked at these formulas, you see that this is very routine math. And you can do that in Excel. It makes it a lot easier and a lot quicker, believe me. So in order to do this and get this into Excel, there's 4 different variables you have to think about. Present value, future value, interest rate, and how long are you waiting. So those are the 4 variables that you need to worry about. And in order to get a solution, you have to have information about 3 of them. So you got to look at these problems and figure out what do I know and what do I not know. And when I don't know something, I need to somehow figure it out. In real life, you're going to actually be looking to actual data to figure out the answer. But in these problems, it's usually given to you. And that's why we want to do a project so that we can actually practice putting this all together, because it's a bit hairy, just let me say. These spreadsheets get pretty hairy. So again, with present value, we're trying to get everything in terms of today's dollars, right? So that would be year 0 or times 0. You enter benefits as positive and costs as negative, because cost is money going out, benefits are money coming in. So you need to make sure that you put that in there because this is a common mistake. And then when you're doing future value, then you need to really say, well, when did these benefits occur? Are they in the same time period? And if it's the same amount, they may be called an annuity. Now let's just talk briefly about the interest rate. Interest rates are very confusing because there's tons of them. If you look in the paper, there's a constant preoccupation with them. If you listen to the business news, we're obsessed, completely obsessed with them. And why? Because it's really a measure of someone's cost of waiting. If you go to a bank, for example, they'll pay you less than 1% to save money with them. So you're not really going to be motivated to save if that's the interest rate you're getting. And in real life, there's a lot of interest rates. So they are difficult to determine, but I'll talk a lot about how we get them and what we do with them as we go through the class, but it is something the students are always confused about. For me personally, I do have costs of waiting. My personal cost of waiting is very low because I'm into sustainability, so I will wait a long time. But for my business, I do have a cost of waiting. I want really to earn 16% before I'll invest in a project. So if that project isn't going to give me 6% return, I won't invest in it. That's a pretty reasonable cost for a business. So if I don't get 16% of it, I'm not touching it. But let me be clear that some of us sometimes make silly decisions. I say my cost of waiting is very low, and I don't borrow money personally unless it's invested in my business. The only money I borrow is for my mortgage. The rest of the time, if I use a Visa card, I pay that off immediately. Because if you're using a Visa card and you're paying 12%, that's telling you that your cost of waiting is 12%, because you would rather buy it now and pay 12% on that Visa card than wait. So think about that, because you could be paying for that lunch you had 3 years ago for the next 10 years if you're only making that minimum payment. So when you spend on a Visa card or spend on credit, think about it as this is what I'm paying to consume now versus waiting. That's why all the personal finance people will tell you, do not borrow money unless that interest is tax deductible. And the only interest that's tax deductible is for your mortgage. So they're always telling you, save, 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 and do not borrow on credit, because that actualizes that cost of waiting in the form of the cost of that credit. So was that purchase so wonderful that you're willing to pay 12% for it? Think about it. No one thinks about it that way because it's so easy to pull out that credit card. And in reality, interest rates change every day. So it might look good now, but look bad in the future. This is a constant obsession of business because we're always worried about what's the cost of waiting. Some of the cost of waiting is reflected in the cost of borrowing. So that's why we're so obsessed with it. Usually the interest rate is expressed in annual terms. If it isn't, we'll talk about how to alter it so that you can get it. Maybe, for example, some of us get paid interest quarterly. Some of us get paid in interest daily on our savings accounts. So we can account for that in these formulas when we're putting it into Excel. Time period is usually in years because that's just kind of how we think. If it's not, then you'll have to adjust the interest rate. So if you're paid interest quarterly, then you have to use a account or a division to take an annual rate and make it quarterly. Sometimes you will make an investment and that return will go on forever. And when you do that, it's called in perpetuity. It will go into infinity, and there is a formula that you can use to do that. And it is right here. Here's the perpetual annual sum, so it goes on forever. If you get a return, we will have a problem in one of the assignments where this return from investing into something goes on forever. Then all you do is you take that annual sum, whatever that benefit or cost is, and multiply it by 1 divided by the interest rate. That means you will get this return from this investment forever. So That's how you do a perpetual sum. So again, now, what are we doing? We're going to try to solve for present value. That's most of what we do in this class. And what we're trying to do is do the calculation that will take all these things and move them all back to times 0. So again, this layout is what we're looking for. That lends itself to your spreadsheets, and we're going to get to our Excel example. But one more thing we got to cover before we do that. Inflation and discounting. This is a problem. Normally what we see is nominal values. All prices are affected by inflation. This is one of the reasons why we want to be paid to wait. As you hold $1 in your hand and we have inflation, it loses value as I hold it. This is why we put it into an account. So when you put it into an account, you want that account to pay you back for the actual weighting that you did and also for the loss in the value of the dollar because of inflation. So there's 2 ways we can do this. The thing I usually do is I use the real rate, which doesn't account for inflation, and then I don't inflate any of the benefits or costs that I use when I'm doing my benefit cost analysis. The other option is that we use a nominal rate and we account for inflation. I'm going to show you, once we get to our Excel spreadsheets in about 5 minutes, that if you use the real rate, it's much more conservative. Accountants are very conservative. I am very conservative in my business, so I always use real rates and I ignore inflation. But some people don't ignore inflation and they use the money rate. So if you use the money rate, that is equal to the real rate plus inflation, not minus. I don't know why, typo, sorry, I'll fix it before I post it. So that's usually what we do. And now we're going to go to these Excel spreadsheets. So I'm going to stop sharing this one and I'm going to go to another share of what this actually looks like so you can start practicing it. It's a bit confusing. So where is my Excel spreadsheet? This one. Okay. So here they are. Let me make it bigger so you can see it. Well, let me just blow it up. Okay. So we're going to start up here. So here's how you figure out present value and net present value. So we're going to start with the first example. So the first example, you notice here, we get $100 in year 1, $100 in year 2, and $100 in year 3. We simply cannot add these up and say we get $300. We don't get $300 because we have to wait. And so if we have to wait, we want to figure out what the present value is in year 0. Please notice that I put the years as numbers. I didn't put year 1. I put 0, 1, 2, and 3. And you'll see why this is as we get through this example. So we want to figure out what's the present value of this $300. So there's a formula, and you pull it down from the function right here in the insert. You go to function, and you will get a formula builder. And you will see things like PMT, NPV, sum. So this is what you use to build that formula. Personally, I don't do this that much. I can remember my formulas, so I'm going to show you what a PV formula is. So there's my label, and over here I put in the formula. So how do I figure this out? So this equals NPV, this is the interest rate, and then this is the range. So if I were to do it over here, you can watch me build it. I'm going to say equals, and I want to get the net present value of these 3. So I'm going to say NPV, and then put in a paren, and then all of a sudden you'll see the formula appear underneath. So the first thing I need to put in is the rate. I think I used a 0.1, then a comma, and then I'm going to these 3 ranges. These are the things I want to, and you notice I could put them individually, 1, 2, 3, or I can give it a range. So if you're giving it a range, you just go to them and you notice I highlight, and then I put close paren, because you see I close the paren. So these are the 3 I'm going to discount. They are in order. If for some reason, say we didn't get anything in year 2, I would have to put a 0. And this thing will automatically know that you're discounting these things. The first one is discounted 1 year, the second one is discounted 2 years, and the third one is discounted 3 years. So then you hit return, and there is in fact the answer. And that's how I put it in. It's the exact same formula. Exact same formula. That's how you do it. So either you go to the function table and insert the function, MPV, and then it explains it to you. So if you go down there, you'll say more help on this function. If you click on more help on this function, it will sit and explain how to do it. Or you can just, like I do, learn after you get familiar with this, you just load the formula and you just start typing it in, because it will give you the formula as you load it in. So now let's look at, I'm saying this is the PV. So this is exactly the present value of 100, 100, and 100 received over a stream of 3 years. It's not really an NPV, even though the formula says it's an NPV. Could we get more confusing? Here is the actual NPV. And the reason why I know it's an NPV is because right here, I didn't have anything for 0 years. So the first year you didn't put anything. All you're doing is moving this back to now. So if you're doing an NPV, you have to set up, and right here is a negative. So what does that mean? That means that's a cost. You spent $400 and you got $150 in year 1, $150 in year 2, and $150 in year 3. What do you prefer? Keeping my $400 or spending it and getting back this stream? You cannot add up the stream. You can't just say 150 times 3. It's not going to work, because you had to wait a lot of time to get that 150. So here's actually where I put it in. I'm going to load this up for you so you can see it. But over here, I'm going to now type it in for you real time so you know what I'm doing. So equals MPV. I'm going to type in the interest rate, 0.1. I'm going to give it the range. Same like last time. That's what's got to be discounted. So that's everything that's going to be discounted. And then I'm going to subtract the number that doesn't have to be discounted, which is this 400. Or actually, I'm going to add it because it's entered as a negative number. So I type that one in. All you got to do is highlight it and hit return. And you'll see that this is not a good investment, because the value of this $150 stream of benefits plus the cost, the initial cost in year 0 of a $400 gives me a minus $26.97. So I have 2 options. Either I can lower my discount rate and it will make it look better, right? Let's say we're not earning 10% on this thing. Let's try another one. So let's try a 5%. And then we're going to take the stream again, discount it, add in our initial investment, and how much did it earn if my cost of waiting is only 5%. Oh, what happened? Oh, something's wrong. Oh, yes. It got worse. Why did it get worse? Because the cost of waiting changed. I don't think it should have, though. Oh, I know why. Because when I put in the interest rate, I gave it a 50% interest rate instead of a 5%. So I have to troubleshoot it. So it barely breaks even at a 5% interest rate. Another formula you can do is the IRR, and that will tell you what you're actually earning. And to do the IRR, it's really easy. You just put equals IRR, that's the function. You can either type it in hard or you can go to the function under insert and find the IRR. So you just put in the values and it will tell me what discount rate will result in breaking even. So I'm earning a 6% on this investment. Very good to know. This is a 6% return with this stream right here. A $400 investment and I make $150 a year for 3 years. So that I make 6% on that. So that's an IRR. Okay. So that's, you know, whatever. I don't know what happened to my future example. So we'll create one. So that's how you do an IRR, and that's what the formula looks like. And remember now, back in the day, you had to do this all by hand, so it was a search and destroy. So it's really nice to be able to use the computer. So let's look at the, I don't know why it didn't say. Okay, so let's try and say, okay, we're going to have $100, and we're going to save $100, and we're going to save $100. And we want to know what we have at the end of 3 years. So we want to know its future value. And so when we put in the formula, equals future value, put in that paren, and then it will say the rate. So we had a 10% rate. Then we had the number of periods. We got 3 periods, 1, 2, 3. So you have 3 periods. And how much are we putting in? $100, right? It's negative because it thinks you're putting in $100, and at the end of 3 years, you can take out $331 out of the account. So in this case, this negative sign is throwing you off, but that's the way it calculates, because it's usually used for making payments. I pay $100, $100, $100. Either that, or the other option is you put a minus, like I'm saving, so I'm giving away $100. This is another problem I have, is I do not hit return. So I put in a minus. I have to hit return. Then I go to the next one. I can change that one. So I can put in a minus because I put $100 out of my pockets. I'm not spending it. And $100. And then right here, recalc. Right, because they're all $100. And then it comes out positive. So you get $331 at the end of 3 years. So that's how you do future values. And now let's try an example where you're doing inflation. So if the real rate was 4% and inflation was 3%, then that means your nominal rate is 7%. 4% for the cost of waiting and 3% to cover inflation gives you a total rate of 7%. So there's 2 ways you can do this. You can use the real rate, which means we don't worry about inflation. And if you look at that formula, what that turns out to be is NPV, right? Then I'm having my real rate, which I'm going to locate here. So if you don't hard type stuff, then you can change the real rate and recalculate a lot of times. So I'm trying to get you to stay away from hard typing, but actually putting in ranges. So here's my range of net benefits. And then I have to add in my initial investment. And my rate of return is $16.26. So at a 4% rate of return, I'm making a positive amount. But if I use MPV nominal, then what I have to do is I have to inflate these 3 different cash values, because otherwise they won't be accurate, because I'm going to discount by the nominal rate. So here is where I inflate them. Here's how you do that. So it's 1 plus that interest rate, or that inflation rate, which is 0.03, raised to the power of 1, because you're only getting interest for 1 year. And where did I get that 1? It says D4. Where is that? Well, that's right there. This is D4 right here. So I don't have to keep track of what year I'm in. I just go to the year column and I just put it in. Much easier. So this is now 1 year of inflation. This is 2 years inflation. This is how we get sticker shock. You see, at the end of 3 years, with only a 3% inflation rate, this value has gone up by $14. So this is what we call sticker shock. Inflation creeps up on us because of this discounting. This is why I don't like to forecast inflation. It really blows up those cash flows. You see how much it blew up these cash flows compared to not using inflation. And so I'm very conservative, so I try to stay away from that, and I use all real rates, which are generally lower because you take out the effect of inflation. And that's why I do it, because it's very hard for me to fathom working 20 years from now. What's the inflation factor for 20 years? This is so difficult to project. So I do everything on real terms. And sure enough, you notice down here, when I do the nominal, let's do that calculation. So it equals the MPV with the nominal rate. Put in your comma, then you put in your things that have to be discounted. Then you put in your cost in year 0, which does not have to be discounted. And you hit return, and you get that the value of this in present day dollars is $17.19. So sure enough, even with a 0.03 inflation rate, which is relatively low, still it's more. It's almost $1 more because of that effect of compounding inflation. So we have one more quick one and then we'll be done, and that's how do you calculate a payment. So if you want to borrow $400 and you need to pay it back over a period of 3 years, and you have an interest rate of 8%, and you want to have it all paid off, there's the formula. It's the PMT formula. So let me show you how to do it. You go over here, equals, we want to have a same payment every year. And you could do it also if you were buying a car, a monthly payment or a house loan. You can figure this all out. So what's our rate? There's our rate. How many number of periods? We put in a comma. Then we go to our number of periods. We put that in. Then we go with another comma. And then what's our present value? We borrowed $400. We want to have a 0 future value type. What that means is, are you paying at the beginning of the month or the end of the month, beginning of the year or the end of the year? Usually we go at the end of the period or at the end of the month. Hit return. And you need to pay $155.21 every year for 3 years to pay back that $400 if you have an 8% interest rate. And you notice that's significantly more money than what you borrowed. And that's really the problem with borrowing. So we're going to stop the share. I'll upload this and the webinar. Sienna, do you have any questions?
I have a question, but I don't think it needs to be recorded. It's kind of unrelated to today's.
Okay, so I'm going to stop.
Okay.